I welcome you all in this session. Today we will discuss AO star algorithm, that is AND or star algorithm. Before moving to AO star algorithm, we will first revise our previous topic, that is A star algorithm. Then we will move on to AO star algorithm. So as discussed in the previous session, A star algorithm is best known form of best first search. It avoids expanding paths that are already expensive but expands most promising path first. And in order to calculate the total path to reach our goal, we will use this formula f of n equals to g of n plus h of n, where g of n is the cost to reach the node and h of n is heuristic value and f of n is the estimated total path to reach our goal. Here heuristic function at a node n is an estimate of the optimum cost from the current node n to a goal node. That means h of n is nothing but an estimation of the optimum cost from the current node to the our goal node. So we will see this example. To understand this algorithm, we have to move from our start node S to our goal node D, and in this graph values are given for g of n, and for h of n we will use this table at the right hand side. So we will start from node S and move towards node D, and we will use the formula f of n equals to g of n plus h of n. So g of n is given in this graph and h of n is given in the table. So first we will calculate for node S. So for node S, f of n will be 0 plus 7 equals to 7. So g of n for node S is 0 because we are at the node S. So g of n will be 0, and the heuristic value for node S is given as 7. So 0 plus 7 equals to 7. Now we are having two options. From node S we can move towards node A and we can move towards node B. So we will calculate f of n for both the path. So first we are calculating S2A. The f of n for S2A will be 1 plus 6. So S2A, it is having value 1 of g of n, and for node A the h of n will be 6 given in the table. So 1 plus 6 equals to 7. Similarly, for S2B the f of n will be 4 plus 2 equals to 6. For S2B the value of g of n is 4. It is given in the graph, and the heuristic value for the node B is 2. So 4 plus 2, it is 6. Then we will write these explored path at the right hand side for our convenience. And then now we will check from the right hand side which path is having less value and is unexplored. So currently we are having two paths, S2A and S2B. So we are having minimum value 6 for S2B. So we will select S to B first. Then from S to B, we can move towards node C. So we'll calculate f of n for the path S to B to C. So for S to B to C, the f of n will be 6 plus 1. So S to B to C, it is having value of g of n as 4 plus 2, that is 6, and the h of n for the node C is 1. So 6 plus 1, it is 7. So we will write at the right hand side. Then we are having unexplored path, that is S to A and S to B to C, and both are having same value. So we are selecting S to A first. So from S to A, we can move towards node B and towards node C and towards node D. So we are having three paths. So we will calculate f of n for all the three possible paths. So for S to A to B, the f of n will be 3 plus 2 equals to 5. Then for S to A to C, we will have f of n equals to 6 plus 1 equals to 7. And for S to A to D, we will have value of f of n as 13 plus 0 equals to 13. Because for S to A to D, S to A is 1 and A to D is 12. So it is 13, and value of h of n for the node D is 0. So 13 plus 0 equals to 13. So we will write all these three paths at the right hand side. Now we will check unexplored path and having the minimum value. So we are having S to A to B, it is having the minimum value, that is 5, and is unexplored. So now from S to A to B, we will move towards C. So for this we will calculate f of n, and it gives 5 plus 1 equals to 6. So S to A is 1, A to B is 2, it is 3, and B to C it is 2, so it is 5. So 5 plus 1, and the heuristic value of node C is 1. So 5 plus 1 equals to 6. Then we will write this path at the right hand side here. Now we will select unexplored and minimum value path. Now we are having S to A to B to C as minimum value, and we will move towards D using this path. Now we are having f of n equals to 8. So we can see S to A is 1, A to B is 2, B to C is 2, and C to D is 3. So 1 plus 2 plus 2 plus 3, it is 8, and heuristic value of D is 0. So 8 plus 0, it is 8. Now we will write this path at the right hand side and then select unexplored and minimum value path. Then we are having S to B to C as minimum or and unexplored path. Now we will move towards D using this path. So S to B it is 4, B to C it is 2, and C to D it is 3. So it is 9, and heuristic value of D is 0. So 9 plus 0, it is 9. Now we will write this path at the right hand side here, and we will select the path which are unexplored and having the minimum value. So we will have S to A to C as the minimum value and unexplored. So we will use this path and move towards D. Then f of n will be, so S to A is 1, A to C it is 5, and C to D it is 3. So it is 9 and heuristic value of D is 0. So 9 plus 0 it is 9. Now we have explored all the path. Now we will write this path at the right hand side here, and then we will check for the path having our goal node D. So we are having 4 paths which are having node D. The first one is S2A to D equals to 13. The second one is S2A to B to C to D equals to 8. The third one is S2A to B to C to D, it is 9. S2A to C to D equals to 9. Then we will check for the minimum value. So the minimum value is 8, the second one. S2A to B to C to D. So it is our answer, S2A to B to C to D, and I have highlighted this path in the graph. So this will be our answer. So similarly, we will work in the AO star algorithm also. So what is the difference? We will see first. The AO star algorithm is best algorithm for solving cyclic and or graphs, and it is applicable where the problem is divided into a set of sub-problems where each sub-problems can be solved separately. So we will take one example. If we want a TV set, then we can acquire a TV set in two ways. First, we can steal a TV, which is not a good practice, but just for an example, I am taking this to understand the concept of AO star algorithm. And the second option is we should earn money and then buy a TV set. So here we can see the first option is a single step solution, but the second solution is two-step solution. First we have to earn money and then we have to buy TV set. Means both the steps should have taken simultaneously. Then only we will have a TV set. So in this type of solutions where two steps should be taken simultaneously, in these kind of situation or problems we can apply AO star algorithm. We can see here we have two solutions, so we have choices in between them, so we have put an OR in between them. And for the second solution, for both these steps we should have to take both the step simultaneously, so here AND. So that's why we are calling it AND OR. So in this kind of situation we will apply AO star algorithm and we will see how we will calculate. So in the left hand side you can see an example. Here if we apply AO star algorithm, we will have answer as 1 plus 3 plus 1 plus 4, that is 9. I have written here. But if you apply A star algorithm here, then the answer will be 3 plus 1, that is 4, which is not a solution. So in this kind of problem you will have to apply AO star algorithm. Similarly, for the example given at the right hand side, I have written all the answer in the graph itself, and for this problem the answer is A to B to E to F. This will be optimal solution. So this is all from my side for this session. Thank you for joining.